let me continue with this example from the previous video. I just want to demonstrate one other thing. Let me put my breakpoint here. Again, hit F5. You can see the call stack. Somewhat clean. We got recurse, 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 recurse. Very cool. Now, stacks are allocated, as far as memory goes, on a thread-by-thread basis. And if you want to learn more about that, go watch the threading videos. But essentially, every thread gets its own stack. We only have one thread in this program. It's the main thread. The stack is not allocated as much memory as the heap. The heap is very large. You can allocate objects on there, remove them. There still is a finite amount of room. Your computer only has so much memory and so much virtual memory and paging it will allow you to do before you use up all that memory. Don't be wasteful. But the stack, same idea. It's finite. It's just a lot more finite than the heap. It's very limited. So we can handle a few calls to recurse, no big deal. But what if I want to come here and say 3, I don't know, let's put some big number out there, 3, whatever that is, million or 30 million or billion or whatever that is. My stack will not be that big. My stack cannot handle that many calls. And eventually, when you hit the end of the stack, the runtime detects that and says, well, I'd like to add more, but we're going to go out of bounds. Okay, let me just run this. F10 and F11 on recurse. I'm actually going to move the breakpoint down here to recurse and hit F5. You see we have our first recurse here, and let me hit F5 again, and there's the second one and the third one, fourth, fifth, sixth, seventh, eighth, ninth, so on and so forth. That stack's growing and growing, pretty large. Let me take care of the, get rid of the breakpoint and hit F5. Your mama's so fat she caused a stack overflow exception. Right, notice the stack. It's now huge. And look at all this. All these stack frames. Each one takes 16 bytes. We saw that a few videos back. 4 bytes for the, we're actually in the constructor for counting class. But every recurse call, there's 4 bytes for I, 4 bytes for counting class, and then another 8 bytes. One's for the return address and something else. You can go watch in my assembly programming playlist if you want to. But we have just used up way too much room in our stack. And if you have a stack overflow exception, generally you're doing something wrong, some infinite recursion or some mega recursion like so, that you did not intend to. But if you did intend to go that far, you need to rethink your algorithm, all right? This is just mess up. Look at this. I can scroll and scroll and scroll and scroll, and well, that's not even fair, all right? The maximum number of stack frames supported by Visual Studio has been exceeded. We went too far. All right, let me go back to the top. I'm going to double click on recurse here. Go back to the context of recurse. Notice the green arrow I showed in the previous video. Let's just see how far we got. I'm going to hover over I, and we got 2935592 down. It looks like, what is that, 29 billion or 2.9 billion, something like that. We got pretty far before our mama overthrew the stack overflow exception there. So anyway, yes, stacks are limited. Don't call too deep.